servo gripper, we are using it on our TR. For the pneumatic gripper, we're using it on our AR. So the loading on our TR actually is also using the arm with servo. So our gripper grip the arrow from the arrow rack, and then the arms will rotate to insert the arrows into our shooting tubes. This is one of the sliding mechanism on our TR. Sorry. Okay, so basically, the sliding mechanism will pass the arrows to another grippers in order to load the arrows into the shooting tube. So basically, it's used to pass the arrows one to another. Next. Okay, so the loading on the AR is actually same, just grips the arrow from arrow racks, and then the arrows will shift to the shooting grippers by using power window motor. So after we shift to the correct position, the shooting gripper will grip the arrow and shoot the arrow using the rubber band. Okay, so for information, AR is arrow kit robot, and it was created to assist our TR. So during our TR failed to shoot the arrows into the pot, the AR will pick up the arrow from the ground. So basically, our pickup mechanism is using servo motor to grip the arrow. So basically, our robot will move to the location of the arrows and pick up manually. Okay, so next, I will talk about the improvement of our robot during Abu ROBOCON 2021. So basically, we reduce all the movement for the robots, and this can achieve the one-point shooting. So that means our robot will not move from one point to another location to shoot the arrows. So this will reduce the movement, and also we also remove the static shooting mechanism in order to reduce the weight for the robot. So here is our video during our training for UTMA. So as you can see, our robot will only shoot in one position. You see the TR, it only shoot inside of the arrow rack. So this will increase the stability and accuracy. As well as our AR, we only rotate the shooting mechanism to shoot the arrow. We will have team B, UTMA. So basically, the robot designs are the same, but the strategy, in terms of strategy, is totally different. As you can see, our TR will shoot the arrows to the furthest target until the nearest target. So this will also increase the accuracy. The best time for UTMA is 35 seconds, and the best time for UTMB is 36 seconds. And so that's all for mechanism. I will pass to our electronics member, Sui Xiang. Thank you, everyone.
Okay, thank you, Sherman. I'm Sui Xiang, and I will be talking about the electronic parts now. So in UTM ROBOCONs, normally we customize our circuit boards. So why are we doing that? First, we customize it so that it suits our style, like it can follow all our standards. So another advantage is sometimes you buy the commercial boards, they have a lot of different functions, and sometimes we don't really use all of them, we only use some of them. That's why we customize it to make it like we can fully optimize it, fully utilize the board. So it is to maximize the whole electronic system performance. Next. So here is a brief summary on how our electronic system works. So as you can see in the middle, like there is two main electronic boards, which is the main board with ARM IC and the robot navigation systems, RNS. So for the RNS, it is used specially only for the navigation. So we use this to control all the navigations. For example, like if we are using the 3 points omnibull base, we will connect the three motors to this board, of course through the motor driver. Then besides that, we have the encoder to like assist the robot navigation system, so that we can know that how many turns have the motor rotates. And also the IMUs will be connected to the RNS also. The IMUs, to be simple, it is a inertial measurement unit. It acts as something like a compass on your robots, so that you will know how many degree your robots rotates, like the robot's rotation angle. Okay, so for the main boards, normally it gives signals to all your functional parts and also receives signal from the sensor. So as we are using the pressurized air shootings and the pneumatics gripper, so we will need valve. Then the main boards will give signals to the valve drivers and then to control the valve. For the besides that, to control the motor driver, we will use main boards giving signals to the motor driver to control the power window. Then because you can see that we use a lot of servo for the robot's arms rotations, the servo gripper. So we will use mainboards giving signal to the servo drivers and then to control the servo. So other than that, the sensors will give their feedbacks to the mainboard also, and the PS4 controller will be connected to the mainboard. Then we also added one LED indicator. It is used to make our programmer life easy, so that by looking at the LED indicators, they will know that what conditions, like what modes the robot's currently at. And also the last one is the emergency button. So we normally use connects the emergency buttons to cut off the signals to the motor, so that once the robot is lost control, then once we press the emergency buttons, all the navigation systems, all the motor will stop immediately. So for the safety precaution. Next. Okay, so if you want your robots to go fully autonomous or semi-auto, you need to get some feedbacks from your robots, and we use sensor to get them. So here's a few examples of sensors that we using during last year competition. The first one is the distance sensor, or we call it as the laser sensor. It used to detect the distance to get the accurate distance. So the second picture is the limit switch. The working principle is quite simple. Like if you hit the limit switch or you touch the limit switch, then it will give signals to your main board. So if your limit switch is not pressed, then it will give no signal. So the third picture is the laser pointers and the LDR. So for here, we actually use the properties of the light-dependent resistor, LDR, which we know that the LDRs will have a high resistance during the dark environments and low resistance during the bright environments. So we use the laser pointer to stimulate the environment. So, and we will show how we implement it later on. So the last picture is the photoelectric sensor, or in UTM ROBOCON, we will call it as the analog sensor. The working principle is quite similar to the limit switch, but the only difference is limit switch, it requires the physical contact. You need to hit it, you need to press it. For the analog sensor, you don't really need to have a physical contact. So for example, you can set the distance range at about 10 cm. So once something's go within 10 cm, the photoelectric sensors will give signals to your mainboard. So it is more than 10 cm, so it will give no signal. Okay, next. So, and also the infrared sensor and the encoder, like I mentioned earlier, is used to know how many turns your motor have rotated. Next. Okay, so here is some of the example of how we implement it. So in this one is we use the laser sensor to get the distance to position our robots by using the fans, like the outer fans, as our reference, so that our robots are always in the same positions while shooting. Next. Okay, so this one is for the analog sensor. You can see that in between that two circles, there is a red light there. So there is actually the analog sensor. Then when the shooting mechanisms, like the reload mechanisms, go backwards, the analog sensors will sense the black bar over there. So it means that the shooting range, the shooting distance is enough. Then it's ready to go for the next step. Okay, next. So here is how we implement the limit switch. As we want our robots to stick to the back fence every time during shooting, so the limit switch is actually located behind the robots. So when we stick the fence, the limit switch will be pressed. so that we can know that the robot is in the right positions and is ready to go for the next step. Next. So this one is the laser pointers and light dependent resistor. So it is actually located in between the gripper, the gripping mechanisms. You can see the red light there. So like, why are we using this laser pointer and LDR? One of the main benefit is its size. It is really small, so we can put it in between the gripper. But the disadvantage is like it really requires a very high tuning. It's really hard to like really implement it perfectly. So you really need to try and error many times in order to get the best results. Okay, next. So here I'm going to share about some of the UTM ROBOCON's wiring culture. So prepares all the electronic boards and wiring and wires before wiring. So normally during the designing phase, after we finalize our design, when the mechanisms member starts fabricating the robots, we electronic members will start preparing all the electronic boards, all the wires that we need, so that once the mechanisms member have done all the fabrications, the robots are ready, we electronic members can start the wirings immediately. So it is to shorten the whole process and to make everything more effectively. Okay, next is avoids flying wires. As you can see in the diagrams, all the wires are cable ties according to the robot's metal. So like there's always supported by a metal. So we usually don't connect the wires from one metal fly over to another metal. So one of the main reason is like we want to ensure that all our wires are in the safe place. Okay, so then there is no damage of wires during we tuning our robots. So all wires must be wrapped with cable wraps. Of course, you can see in these diagrams, all the wires are cable wrapped perfectly, except for the 3 power cable. So the 3 power cable is not wrapped. It is because it is it's connected to the battery, and we will change the battery very frequently. So it is easier for us. But of course, the wires are in the safe conditions. So last one, the make sure all wires are safe. There, because like in the whole robots, there surely will be a lot of mechanisms, functional parts, especially for those functional parts that have a big movement. For example, servo grippers, like the robot arm, the sliders that may damage your wires. So you must make sure all the wires are long enough and it won't be too tight, won't be too loose, that will affect the whole performance of your robots. Okay, so and the most important part in the whole wiring rule is you have to make sure your wirings, your electronics boards are always in a neat and tidy condition. So because sometimes you won't know when your robots will have some problems. So it is like with a neat and tidy condition, it is easier for you to troubleshoot, to know what is the problems and to fix the problems in a shorter time. So that's all from me, and I will pass it down to our programming members, Chairman Lok.
Hello, can you hear me? Yes. Good afternoon. Good afternoon. My name is Charming Lok, and I would like to share about the programming part of UTM ROBOCON. Next. In UTM ROBOCON, we emphasize on a rigid basic in C programming language on every ROBOCON members. This is because we are going to program microcontroller with C programming language. The microcontroller that we are using is STM32F4 series. And to program this microcontroller, we prefer to program it in an integrated development environment, which is STM32 IDE. In this IDE, we are able to trace the source code of the microcontroller easily so that we can utilize it fully and we can understand the code more easily. Next. In UTM ROBOCON, we do code optimization. Code optimization is a technique to transform the codes. The main purpose of it is to make our code simpler. In UTM ROBOCON, code optimization is always used before the code is applied onto the robot. The benefits of code optimization is to reduce the memory usage and reduce the computing time, and the most important is to stabilize the robot. Talking about closed-loop systems, we use closed-loop systems to control the robots. For example, in our navigation system, we will use encoder values as our input to the control system. And when the encoder value is fed into our microcontroller, the microcontroller will process the data. Then the data is stored in microcontroller for further process. And the output after the processing of the data is fed to the actuator, for example, motor or pneumatic system. Okay, and next. Okay. And we also use master-slave architecture for our robot system. As you can see, mainboard is our master. Mainboard is our master, and all other compartments is the slaves. Slaves can be divided into active slave and passive slave. Passive slaves are slaves that only receive command from our master. For example, servo driver. They only receive signal from master so that it can drive the servo with the signal. Talking about active slave, in this example, the controller, PS4 controller, is our active slave. The signal from PS4 is pre-processed in our slave before it is sent to the mainboard so that the mainboard can perform based on the PS4 controller input. Okay, next. The benefits of master-slave architecture is to reduce the workload of microcontroller, and it is easier to debug this system. Thus, this architecture stabilizes our robot system. Next. In microcontroller, there is such thing called interrupts. Interrupts is, for example, when you receive a signal from, for example, your slave, and you don't want to have any delay to process the signal. So we use interrupt to interrupt the main program so that we can process the signal first. Then after that, we can go back to our main program without much effect on the whole system. So we use interrupts in many cases. For example, PS4 module. The signal from PS4 modules has the highest priority. This is because we want our operators to have our robot under control in any moment. Next. For the speed and accuracy of our robot, when it comes to tuning a robot, speed and accuracy are contradictory. you want the robot to have high speed, it may sacrifice the accuracy. But if you too focus on the accuracy, it may have a drawback on the speed. So we always fine-tune the robot until the sweet spot between speed and accuracy are achieved. One technique that we use is by assigning a suitable tolerance. The tolerance value will be tuned until a smooth operation is achieved. That's all from programming, and I would like to pass back to Li Jia Chen to end our sharing.
That's all for our sharing today. I would like to use this opportunity to thank ROBOCON Malaysia for giving us this opportunity to share our knowledge with other teams in Malaysia. Hope to see you all soon in Penang. Thank you.
Saya sambung. Terima kasih diucapkan kepada Profesor Madya IR Dr. Muhammad Rizwan Ahmad dan pasukan UTM di atas perkongsian yang disampaikan tersebut. Diharap semua peserta mendapat maklumat yang membantu bagi pertandingan ROBOCON Malaysia 2022 dari perkongsian sebentar tadi. Jadi kita teruskan sesi taklimat petang ini dengan sesi soal jawab. Dipersilakan peserta untuk mengemukakan soalan. Mohon perkenalkan diri dan institusi yang diwakili. Anda juga boleh menaik soalan di ruang chat dan saya akan bacakan. Silakan. Sebarang soalan dari bakal-bakal peserta ROBOCON Malaysia 2022.
Semua jelas nampaknya.
Okey, jika tiada sebarang soalan, kita teruskan sesi petang ini dengan sesi fotografi. So, diminta semua peserta untuk mengaktifkan kamera untuk kita buat satu sesi fotografi secara maya. Boleh? Okey, sedia? 1, 2, 3.